So welcome to National 4 and National 5 Chemistry. We are on Unit 1 and the topic for this set of lessons is going to be acids and bases. And this first lesson is going to be an introduction to acids and bases, or acids and alkalis as they're sometimes called. Our learning intentions, we'd want to be able to identify something as being an acid or a base or alkali using indicators, understand the pH scale, understand how to use universal indicator to determine the pH of a material, and also to be aware of different indicators. In terms of success criteria, I can use the pH scale. I can state that acids have a pH less than 7. I can state that bases or alkalis have a pH greater than 7. I can state that neutral pH is 7. And I have used universal indicator and can match colours to the pH scale. So acidity. Acidity is measured on something called the pH scale. Acids have a pH less than 7, and if we're using a coloured pH scale, that represents colours going from red, orange, yellow to light green. Alkalis have a pH of more than 7. And that goes from a dark green colour all the way through to purple. So if it's dark green, blue or purple, it is an alkali. And finally, neutral substances have a pH of 7. You're expected to be able to remember that acids have a pH less than 7 and to know the colour changes that would represent an acid. The pH for alkalis being greater than 7 and the colour changes, and that neutral substances have a pH of 7. Now, what I would point out is that pH, it has to be exactly 7. So if it's 7.1, it's technically an alkali. If it's 6.9, that's an acid. Only 7.0 is a neutral substance. Now, acids and alkalis are found all around us. And you might want to spend this time thinking of any acids that you might use every day, or any alkalis that you might use every day. You also might not have been aware of acids and alkalis around you. And water is neutral, but can you think of anything else that's neutral? Well, this is a pH scale of common household objects, going from pH 0 or pH 1 at the bottom, all the way up to pH 14 at the top. So you can see that things that are acidic, batteries, not the battery in your phone, but your normal batteries, your AA's, your AAA batteries, those are acid, and definitely a car battery is very acidic. Things like lemon juice, vinegar, by soda they mean fizzy drinks, fruit juice, even coffee is acidic, and even things like your saliva and milk are slightly acidic. Water, pretty much the only thing that's spot on neutral. And if we're going into things that are basic or alkaline, your blood and seawater are very slightly alkaline. Toothpaste is alkaline, and then if you look at most of the things found at the top in the high pH range, they're all cleaning products. So drain cleaner, bleach, soap, all of those things are alkalis. So if you actually look across the range, cleaning products are alkali, and things that you eat are close to neutral, so between pH 9 and pH 5. And then we have vinegar, batteries are the things that are quite strongly acidic. Now, indicators are used to help us determine what the pH of a substance is. They will change colour in an acid or an alkali. The most useful indicator is called universal indicator, as it changes colour based on the pH number. So it will be a different colour in pH 1 compared to pH 2, all the way up to pH 14. Most other indicators only have 2 colours, and they will be one colour in an acid and another colour in a base. Universal indicator has lots of different colours. So examples of other indicators, other than universal indicator, is something called litmus. Now, litmus turns red in acids, blue in alkalis or bases, and it's purple for anything that's neutral. So if you're able to do this experiment in class, you'll hopefully get to test several different solutions or different everyday objects with a universal indicator. And then try to organize your tubes from most to least acidic. In terms of natural indicators, nature is filled with substances that can be used as indicators. So herbal teas will change color in acid and alkali. Even normal tea can change color slightly. Green teas get darker. The most dramatic color change is for anything that's got a raspberry tea. You can turn raspberry tea green by adding an alkali to it. Any fruit that's blue and purple in color, if you're able to take that color out of it, you can use that as an indicator. So red cabbage is one of the best examples. It turns pink in acid, it's purple when it's neutral, and it can turn a whole host of different colors, but blue, green, or yellow in alkali. There are also some spices that can change color. Turmeric and curry powder, some quite common spices. They are a bright orange-yellow color, but they can turn red if you expose them to an alkali. Now finally, we need to look at some of the uses of acids. Now acids are used in food. You might be someone who adds vinegar to your chips because you like the taste, and often acids are used to improve the flavour of food. If you ever like any of those fizzy Haribo or the fizzy cola bottles, what gives them that fizzy, sour quality is something called citric acid, which is put on the outside of the sweets, and it gives it that sharp taste. Acids are also used to help preserve food. So if you're using vinegar, that's what we would call pickling something, and that stops bacteria from being able to grow and helps you preserve food. But acids are also added to a whole host of other foods to help them last longer on your shelves. Now, acids, however, do have some harmful effects. If you eat too much sugar, sugar is quite highly acidic, and especially it gets more acidic if bacteria in your mouth start to feed on that sugar. They turn it into stronger acids, and that is what leads to tooth decay. Additionally, if your body gets too much acid in your stomach, that can lead to indigestion and something called heartburn. And the treatment for heartburn is actually to add something that's alkali. So any sort of indigestion tablet is an alkali that helps to eliminate and get rid of some of that acid. So hopefully you can now use the pH scale. You can state that acids have a pH less than 7, that bases or alkalis have a pH greater than 7, and that to be neutral you need a pH of exactly 7. You also are aware that universal indicator is what changes colour to give us the different colours for the pH scale. Those colours are red, orange, yellow for acids, green for neutral, and dark green, blue, and purple for alkalis. Now I just got a few questions to go through. So you can keep these in your head if you're watching the video, see if you can get the right answer. So what pH is neutral? Well, the answer to that one is 7, and exactly 7. What pH is acid? Well, this one, any pH that is less than 7. So that's anything from 0 to 6.9. What pH is alkali? Well, that is any pH greater than 7, so 7.1 all the way up to 14 is an alkali. What indicator can we use to show the full range of pH values? So which indicator changes colour to tell us exactly what the pH value is? Well, that is universal indicator. Can you name a natural indicator? So an indicator that you find in nature. There are lots of different examples. Red cabbage, curry powder, turmeric, tea, beetroot, any of those can be used as indicators. What do we use to measure how acidic something is? We're talking about what sort of scale do we use. That is the pH scale, and we can use universal indicator to tell us where a substance is found on the pH scale, which goes from 0 to 14. So that's been our introduction to acids and alkalis. I will catch you next time where we look at the sources of some of acids and alkalis.